Welcome to the Automated Daily, Space News Edition, the podcast created by generative AI. I'm Trent Teller, and today is August 7th, 2026. Imagine sending a robotic probe to another star system, not in some distant science fiction future, but potentially within the span of a single lifetime. That isn't just a daydream. Some researchers now argue the technology to make it happen is closer than most of us think. 111. We will get to that bold claim in a moment. In today's episode, we will look at how ideas for interstellar travel are edging toward engineering reality, how NASA is quietly reshaping its plans for the moon, and why a single Martian rock has scientists pushing harder than ever for a sample return mission. WTeen 1515. We will also unpack Blue Origin's findings on the New Glenn test explosion, check in on SpaceX's latest batch of space-based cell tower satellites, and wrap up with what you can see in the sky tonight and in the days leading. Up to the big 2026 total solar eclipse, 11817, 9A20N, 9A20. Let's get into it. This episode is brought to you by Gamma. Gamma lets you effortlessly use AI to design for presentations, websites, and more. Find the link in the episode notes. Let's start with that interstellar tease. An opinion and analysis piece published today argues that we might soon have the technology required to send robotic probes to other star systems, well within the timescales of a human life, rather than some far future epic. 11. The author, aerospace engineer Colin McInnes, writing for The Conversation and featured at Real Clear Science, points out that advances in lightweight spacecraft, high-power lasers, and novel propulsion concepts are converging in a way that makes fast, small interstellar missions look technically plausible rather than purely speculative. 11. These ideas build on concepts like laser-driven light sails and beamed propulsion, where intense light or particle beams push tiny spacecraft to a significant fraction of the speed of light. What makes this interesting is not that someone has dreamed up yet another futuristic drive system, but that credible engineers are saying the necessary components are either already in development or under serious study. U11. If we can shrink spacecraft to gram or kilogram scales while dramatically increasing the power and precision of ground-based or orbital beam systems, a mission to the nearest stars could take decades instead of millennia, allowing the same generation that launches a probe to see data return from a flyby of, say, Proxima Centauri. That would transform interstellar travel from a distant aspiration into a long-term engineering project, and it would completely change how we think about studying exoplanets up close rather than only through telescopes. 11s. Of course, there are huge challenges: power levels, beam pointing accuracy, communications across light years, and the sheer cost of building such infrastructure remain daunting. But the important shift here is an attitude. The conversation is moving from asking whether interstellar travel is possible at all to debating what architectures might be feasible in this century and which scientific targets, like exoplanets with atmospheres, should be prioritized once we can actually send hardware there. That change in tone alone is a sign of how quickly space technology is evolving. Next up, a significant but somewhat understated development in how NASA is thinking about the moon. Coverage from spaceflight reporters this week underscores NASA's ongoing pivot away from a long-term focus on crewed operations in lunar orbit and toward more intensive, surface-centered exploration. Clashin'. In practical terms, that means the agency's Artemis architecture is being nudged to prioritize landers, surface habitats, and infrastructure at or near the moon's south pole, rather than treating a permanent human-tended outpost in lunar orbit as the main destination. (2000) 29th human-tended outpost in lunar orbit as the main destination. Dual, but recent reporting frames it as a marked change in emphasis, amplifying decisions that have been accumulating over the past year. This matters because how NASA chooses to structure its lunar program will shape not only where astronauts go, but which technologies get funded and which commercial partners are brought into the critical path. 114. More focus on the surface means more investment in systems like reusable landers, power grids, and mobility on the moon, and potentially less weight on maintaining a large, complex orbital gateway as a constant habitation platform. It could accelerate the timeline for establishing a semi-permanent human foothold on the lunar surface, while still leaving room for orbital elements that support logistics, staging, and science. For international partners and commercial companies, Every adjustment in NASA's priorities tends to ripple outward, influencing everything from industrial roadmaps to where future astronauts from other nations might land. It is also a reminder that space exploration plans are not static blueprints. They evolve as budgets, politics, and technical realities change, and we are watching that evolution happen in real time with the moon. The big picture goal, sustainable human presence beyond Earth, has not changed, but the path we take to get there clearly is, one foresees. From the moon, we move to Mars, where a single rock sample is putting intense pressure on NASA and policymakers to keep the Mars sample return effort alive. A feature at Space Policy Online revisits a rock core collected by the Perseverance rover that many scientists now see as the best candidate yet for holding evidence that microbial life once existed on Mars. U15. The sample, cached in a sealed tube on the Martian surface, comes from a region that shows chemical and mineral signatures consistent with long-standing water and potentially habitable conditions in the distant past. U15. A peer-reviewed study on the sample was published in Nature after refocuses. Gorer's scrutiny, and while it does not prove life, it significantly strengthens the case that Mars once had environments where life could flourish. S15. The catch is that confirming whether there are actual microfossils or biosignatures locked inside that rock requires analytical capabilities that only Earth-based laboratories can provide. Perseverance's onboard instruments are powerful but limited compared to what can be done with advanced microscopes and spectrometers on the ground. That is where Mars Sample Return comes in, the multi-mission campaign designed to bring Perseverance's cores back to Earth. According to the report, however, the program has been under severe budget stress, with a recent U.S. administration proposing to cancel it in the fiscal year 2026 budget request, even as Congress debates whether to restore a fraction of the needed funding. U15. During a recent press conference, Acting NASA Administrator Sean Duffy voiced strong support for Mars science that ties into future human exploration, but crucially offered no concrete path yet for actually retrieving the samples, highlighting just how uncertain the mission's future remains. (15) That creates an unusual tension. Scientifically, the argument for bringing these rocks home has never been stronger, but politically and financially, the campaign is on the edge. If the samples stay on Mars, our best evidence for ancient Martian life might sit inaccessible for decades. If they come back, we may finally answer one of the biggest questions in planetary science, whether life ever arose on another world in our own solar system. Now to the space industry, where Blue Origin has provided much-awaited clarity on what went wrong during a dramatic New Glenn test earlier this year. The company has announced that the explosion which destroyed a New Glenn rocket during a May static fire test at Cape Canaveral was traced to an issue with the main oxygen valve on one of its BE-4 engines. U18. In a detailed social media post, CEO Dave Limp explained that the anomaly originated in that valve, a finding backed up by recovered hardware and subsequent inspection of the engine components. U18. The blast not only destroyed the test article, but also damaged Blue Origin's Sol Orbital L launch site, Launch Complex 36, raising questions about how long the company would be grounded. Monatesput. According to Limp, Blue Origin has now conducted extensive component-level investigations and additional hot-fire tests to fully understand the failure mode. UST-NEST. The fix, as described, involves relatively small modifications to the problematic valve design that can be retrofitted to existing engines, and the company says the updated hardware should be ready by the end of the month. (18) At the same time, engineers are working through the remaining fault tree analysis to make sure there are no lurking issues elsewhere in the system. This update is important for two reasons. First, it suggests that New Glenn's setback, while serious, may not require a wholesale redesign of the rocket or its engine, which would have meant long delays. Second, New Glenn is not just a Blue Origin flagship, it is slated to carry a range of commercial and government payloads in the coming years. Pinning down the root cause and articulating a credible path forward is a necessary step if customers and partners are to retain confidence that the vehicle can become a reliable part of the launch landscape, rather than just a promising prototype. U18s. Staying with launch but shifting to another company, SpaceX has added 3 more satellites to a constellation designed to bring space-based cellular coverage to ordinary phones on the ground. A Falcon 9 rocket from Cape Canaveral recently carried AST SpaceMobile's Bluebird satellites numbered 11, 12, and 13 into orbit, with reporting from Spaceflight Now noting that the mission followed a similar launch of Bluebird 8 through 10, about 6 weeks earlier. Un-17s. The rocket lifted off from Space Launch Complex 40 on a northeasterly trajectory, and the 3 spacecraft were deployed one by one, starting a little under an hour after launch. Mobile's plan to create a network of large, flat-panel spacecraft that act as cell towers in space, connecting directly to unmodified smartphones through partnerships with terrestrial mobile operators. 27s. The latest batch marks an incremental but meaningful step toward that goal. Each new group increases coverage and capacity, moving the company closer to offering continuous direct-to-device service in select regions. 1417. For SpaceX, the mission is one more demonstration of the Falcon 9's role as a workhorse for commercial communications projects beyond its own Starlink system, reinforcing its position at the center of today's launch market. .17. For end users, the promise is fewer dead zones, the ability to send a text or place a basic call from remote oceans, desert. Or disaster-stricken areas where ground infrastructure has failed. There are still many regulatory, technical, and business hurdles before space-based cellular networks become as seamless as traditional coverage. But launches like this one show how quickly the concept is moving from pilot tests to operational scale deployments. If these constellations succeed, the line between space and telecom will continue to blur, and your next emergency message might quietly hop through a satellite overhead instead of a tower down the road. Let's close with what you can look up and see for yourself, starting tonight and leading into one of the decade's biggest sky events. For observers in the eastern United States, the early hours of August 7 bring a lovely and somewhat rare sight, the moon passing directly in front of the Pleiades star cluster in an event called a lunar occultation. 9. Astronomy.com notes that around local midnight into the early morning, a waning crescent moon will appear to plow through the northern part of the cluster, briefly hiding several of its brighter stars depending on your exact location. 9. Those farther west may see the moon all red. Why separating from the Pleiades as it rises, but the pairing will still make for a picturesque scene in binoculars. 9. Later in the pre-dawn hours, persistent observers can also seek out Uranus a few degrees away, though that will require optical aid and a reasonably dark sky. 9. This is all happening against the backdrop of mounting excitement over the total solar eclipse coming up on August 12th, which will sweep across parts of Greenland and Spain, and is already being featured in live coverage plans by outlets like Space.com. .1, NASA's own skywatching guide for August highlights the eclipse alongside the Perseid meteor shower and a deep partial lunar eclipse later in the month, making August a particularly busy time for anyone with even a passing interest in the night. Tsky.Thai. With the eclipse approaching, a familiar pattern has also resurfaced online, viral rumors claiming that Earth will somehow lose gravity for a few seconds during the event. An explainer shared widely on social media, citing NASA, stresses that there's absolutely no scientific basis for that claim. 1.1.1.1 point cause is determined by its mass and structure, and a solar eclipse does not change either of those things in any significant way. You will not float off the ground, or even feel a measurable difference in your weight when the moon crosses in front of the sun. What you will feel, if you are lucky enough to be in the path of totality under clear skies, is the sudden chill and eerie twilight of midday darkness, along with the thrill of seeing the sun's corona with your own eyes. Whether it is tonight's lunar occultation, the Perseids, or the eclipse itself, August is offering several chances to step outside, look up, and connect all these headlines to the real sky overhead. U9, Qantas 1. 2 thanks to our sponsor, 11 Labs. 11 Labs lets you discover the future of AI audio with cutting-edge voice technology. Find the link in the episode notes. That's it for today's rundown of what is happening beyond our atmosphere. We touched on bold ideas for interstellar probes, shifting plans for the moon, and a Martian rock that could hold clues to ancient life, all while the commercial launch world continues to push forward and the night sky delivers its own show. 11 1415 1815 14 17 9. As always, the story of space is not just rockets and instruments. It is a moving target shaped by science, engineering, politics, and the simple human urge to explore. If you enjoyed this episode of the Automated Daily Space News Edition, consider sharing it with a friend who likes to look up and wonder what is next. I'm Trend Teller, thanks for listening, and I'll talk to you again soon.